How many people do we have in here? Chat. Yeah, I'm really happy we got rid of the signatures. That was that was just stupid. Okay, that's start time. So the first thing we're going to do is go through two of the problems from the quiz. So rapid fire. So R1, is this reflexive?
Yes.
Yes. Is it symmetric?
No.
No, why not?
There's like no reverse duplicates of anything.
Yeah, okay, so
But wouldn't that, yeah, because AA and AA are both in it.
yeah, so I have AA in here, right? But I also have the reverse in here, and that's true for all of these, so it's symmetric.
Oh, I thought you need AA in there twice for that.
Well, this is a set, so you don't have multiples of the same element.
Wouldn't it be transitive too then?
Yeah, it's also going to be transitive. Is it anti-symmetric?
No, by definition, it can't be.
It actually is anti-symmetric.
It is?
It is, because remember the anti-symmetric says for all A, B in A.
Oh, I get it.
Yeah, right. If A, B is in R, and A does not equal B, then BA.
That's unfortunate.
That's only half a point, don't worry.
I don't know if I do get it.
Okay, so the anti-symmetric is only about elements that aren't equal to themselves. We don't have any elements. So basically what we have is false implies true for every element in here, right? Because A not equal to B is false. A not equal to B is false for each of these, right? So in this implication, we have false implies something, right? Which is always true. Does that make sense?
Not really.
I think I get it. Can I try explaining it?
Yeah.
So it's anti-symmetric because oh my goodness, I had it in my head. You have elements that repeat themselves, but anti-symmetric only looks for elements that aren't the reverse of each other when it's not equal to itself. So AB is in the set and BA is not in the set, but AA can be in the set.
Yep.
Therefore, because there's no contradictions for anti-symmetric, it can be anti-symmetric.
Correct.
Yes.
That is exactly right. Yep. Thank you. Good questions and comments. Okay, so for R2, we notice that R1 is there, so it's reflexive. Is this symmetric as well? Right, so remember symmetric as you have them backward. Yep, it's symmetric. Is it anti-symmetric? Absolutely not, because we have EA and AE. Is it transitive?
I'm thinking no.
It actually is transitive. And it's because, for instance, you can go E to A, and then we have AA in here from here, and then we have AE, but we can also do EE. So we can, we have we can do the triangle, right? Does that make sense? So we can go from A to E and then to A, which, you can collapse this. Does that make sense? For this one, again, we have R1, so it's reflexive. Is this one symmetric?
No.
Nope. Oops. And it's not symmetric because
There are one-way arrows.
yeah, exactly. Is it anti-symmetric?
Yes.
Yep. And is it transitive?
Yes.
Yep, exactly. Any questions on that?
So this
Okay.
one isn't symmetric because there are some things that
Yeah.
contradict symmetry, but there aren't any things that contradict a anti-symmetry.
Yeah. Yes. So BA, but we don't have AB, so that's why it's not symmetric. This one, is it reflexive? I think it's pretty clearly no. Yeah. Is it symmetric? Yeah, we don't have BA in there, so it can't be. Is it anti-symmetric? No, because we have CD and DC. Is it transitive? No, because we can go from C to D and D to C, but we don't have CC in there. So it's not transitive, so it's none. Yeah, no CC, as Brendan says in chat. So for this one, we have A cross A. So basically, it's A, B, AC. So is this reflexive? Yep. Symmetric? Yep. Anti-symmetric? Nope, can't be anti-symmetric. Transitive? Yep. 1 second. And then finally, R6, is this reflexive? Nope. For instance, we don't have AA in there. Is it symmetric? Yes. Yes, it is. Right, we have DA, AD, BC, CB, BB, so that's symmetric. Is it anti-symmetric? No, because we have AD and DA. Is it transitive? No, because again, we would need AA in there because we can go from A to D, D to A, but we can't go straight from A to A. Yep. So it's just symmetric. Okay, so which one of these is a function? Is R1 a function?
Yeah.
Yep. Is R2 a function? Nope. R3? Nope. R4? No. It's not a function because it doesn't have E. I didn't put that in there. So it's not a function. Is this one a function? No. We have A, B, and AA in there. And is this one a function? Why is R2 not a function? Okay. So R2 isn't a function because we have AA and AE, right? So it can't be a function because we have one thing mapping to two things. Yeah, yeah, back to R6. Is this a function? No. Yeah, so just R1 is the function. So which ones are partial ordering? So does anyone remember what a partial ordering means? Yeah, we have a question. Do functions have to be one-to-one? Functions don't have to be one-to-one. What you need for a function is for every element, for all A in the domain, there is one and only one B in the codomain such that A, B is in the relation. So exist exclamation point is unique. That's not one-to-one, no. It's different from one-to-one because this doesn't say anything about two elements in the domain going to the same element in the codomain. It just says that it goes somewhere. Good question. Okay, so what do we need for something to be a partial order?
For that, it needs RAT. It needs reflexive,
Yeah, it needs a
antisymmetric,
RAT.
and transitive, right?
Yeah, so from that we have R1, R3, and that's it because the rest of them don't have, those are the only two that have antisymmetric. And for equivalence relation, we need RST. So R1, R2, and R5. A note on how this is getting graded. If you messed up here, then and your answers are consistent down here, you won't be penalized. So if that's worrying to you. Okay, any questions on that? Yeah, that one's easy to screw up. The function one is easy to screw up. So no other questions? Okay. Yeah, I prefer not to have cascading errors in grading. So the grading rubric does not have cascading. If you miss the union with, yes, you will get partial credit. You'll miss half a point if you got S and T. I'm not going to grade your quiz here though. Okay, so for this one, we have this relation where we have pairs in the integers, and it's in the relation if their sum is even. And we're asked to prove if it's reflexive, transitive, and finally show that it is not antisymmetric by finding a counterexample. So for reflexive, we need to show for all x in the integers, x is in the relation. And so for this one, you just say, okay, so x plus x equals 2x, which is even. So xx is in R and R is reflexive. Any questions on that? That one was pretty easy. So transitive, this is just one way you could have done it. So we need to show for all A, I'm going to use XYZ, XYZ in Z product Z, if X, Y is in R, and Y, Z is in R, show X, Z is in R. So we can do, so X, Y in R implies X plus Y equals 2L for some L in the integers by even. And similarly, YZ in the relation means that Y plus Z equals 2K for some K in the relation because it's in the integers because it's even. Okay, so we look at these two, we can say X plus Y plus Y plus Z equals 2L plus 2K. Then we can do X plus 2Y plus Z equals 2L plus 2K. And that implies X plus Z equals 2L plus 2K minus 2Y. And that's equal to 2L plus K minus Y, which implies X, Z is in the relation. Do you want to see another way to do that one, or is that enough? I noticed that you had two common solutions. Any questions on that? I'm gonna say no. Yeah. Could this have also been done for two cases? Yeah, okay, so let's do that one. So let's say we have XY is in R and Y, Z is in R. So we know that this means that X plus Y is even. If X is even, then Y is even. Y and Z, Y plus Z is even. And because Y is even, Z is even. So X plus Z is even. And you can do this same argument with odd, not odd there, with odd right here. And conclude that all of these are odd, which means X plus Z is odd. So that's another way you could have done this. And I would say about a third of you did it that way. So any questions on that? Okay. And then finally, anti-symmetric. I'm just going to ask for the counter example. I'm hoping it's the one that like 90% of people did. So we're trying to show that it's not anti-symmetric, this relation.
Do what, 2 plus 4 and 4 plus 2?
Exactly. I don't know why, but that is like 90% of them. That's the one I came up with too. So we have X, Y is in the relation because 2 plus 4 equals 6, and Y x is in the relation because 4 plus 2 equals 6, and these are even. Yep, and it all stems because addition is commutative, as David mentions. So any questions on that? Yeah, we are all a hive mind. Yeah, any two even numbers would have worked, and any two odd numbers would have worked. So like 1 and 3 works as well. Yep. Okay, so this is the one where we're going to try to do a breakout room. So for this one, we're trying to find the total space, and then the number of events. So the event is E is John rolling higher than Jessica. And the total space is all roll combinations. So I don't think you get my screen when you're in a breakout room. So take it down from, does everyone have this down? Or enough people? And try to come up with the probability. So we're trying to find probability of the event, which is equal to the number of E divided by number of S. So give you a second to take that down, and then I'll put you in breakout rooms. How many participants are there? Okay, yeah. Yeah, okay. I'll give you about 4 minutes. Oops. Is everyone back? Where's the participants? Okay, everyone's back. Okay. So do we know what n of s equals? Does anyone want to tell me? Yeah, okay, so we have an 8-sided die and a 6-sided die. So we have 6 outcomes. Let's do this in order. 8 outcomes for the first, for Jessica's die, and 6 outcomes for John's die, and that's 48. Okay, so what's the number of events? Does anyone know? Okay, yeah. Yeah, okay, yeah, that's fine to manually add them. So I'm seeing 15, but I manually added them. Yeah, so 5, 4, 3, 2, 1. So we have, 6 possible things that could have happened. So John rolls a 6, and how many ways could that have happened for him to be higher? Yeah. Yeah, it's going to be a pain with a d20. So if John rolls a 6, then there are 5 rolls higher, lower than 6. Similarly, we have for 5, we have 4 lower rolls. For 4, we have 3 lower rolls. For 3, we are rolling for initiative. There are 2 lower rolls. For 2, there's 1 lower roll, and if John rolls a 1, he's not gonna win. So if we do 5 plus 4 plus 5 plus 4 plus 3 plus 2 plus 1, we get 15. So the probability of John winning is 15 out of 48. And that's equal to, factoring out a 3, 5 out of 16. Any questions on that? Is there a syntax for adding up the numbers? I mean, just I equals 1 to 5i, that's about it. Someone asked about if there's an equivalent syntax like 5 factorial. That's pretty much it that I know of. How do we put that into a calculator? Oh, okay, yeah. So we have this formula, which is n times n plus 1 over 2. So this is what this is equal to. So we would get 5 times 6 divided by 2 equals 15. They call that Gauss something because he was a smarty pants in school or something. Anything else? Okay. Okay, so we have a non-negative integer whose solution is equal to the equation this. So w plus x plus y plus z equals 10 is chosen at random, each one being equally likely to be chosen. What is the probability that in this particular solution, w is less than or equal to 2? So let's first worry about the size of the sample space. So does anyone recognize how we can count the sample space?
I do.
Yes, what is it?
This is like a bag problem. So
This
you do choose 10 plus the number of elements minus 1 out of 10.
Yeah,
Right.
so we're doing 10 plus 4 minus 1. And since I want to write down what this actual number is, I'm going to cheat. Because I am not calculating that live. And that's equal to choose 10 from 13. And that is equal to 286. Does that make sense to everyone? How we got that? So just for someone looking later, bag problem. Okay, so now we need to count the number of events. So what is our event? It's w is less than or equal to 2. It would be nice if this were a bag problem, but we don't know how to solve this. Does anyone have an idea how we can turn this into a bag problem? So think of the complement event. Okay, yes, sort of. So we have a suggestion that we do x plus y plus z equals 8. That doesn't quite work because w still can be like 3 or something.
Can you solve the equation for w and do a bag problem like that? I mean, maybe.
I think it's going to end up being the same thing. So remember, we have the complement rule. So we have probability of E is equal to 1 minus the probability of not E. Sorry. And that's equal to 1 minus number of the complement event, or the sample space. Yeah, so what we want to find is the complement event. So what is the complement event? So it's not so W needs to be greater than or equal to 3, right? Because it can't be 2, 1, or 0 anymore. Does that make sense? So what we can do is we can say, okay, we have 10, we have 10 slots. 1, 2, 6, 7, 8, 9. And we say that W is taking up at least 3 of these slots. And then we're going to put W, X, Y, Z over the remaining 7 here. So so for counting this, we can say n of the complement equals choose. So we're now trying to find W plus X plus Y plus Z equals 7. Does that make sense to everyone? Yep, I'm seeing the answer in chat.
Is that that's just because 10 minus 3 is 7?
Yeah, because we already said W is at least 3, right?
Yeah.
So we subtract 3 off 10. So this is going to be, so we're now concerned about 7 things. So we have 7, 4 things we're putting it on, minus 1, and we're taking 7 of those, right? So if you calculate that out, you get 10, choose 7. And I happen to know that's 120. You will not be calculating numbers this big on the exam, just for future reference. Or if you do have them, we will give you the numbers. So we now have the number of the complement event and the number of the sample space. So we can now apply our probability. So we can say the probability of the event is equal to 1 minus probability of not the event. So this is the complement. And that is equal to 1 minus the number of not events divided by number of samples. And that's equal to 1 minus 120 over 286. And since I'm not going to do the math on live, that's 8. So what is 286? It's 166 over 286. And apparently in reduced form, that's 180, not 183. 83 over 143. And if you care, that's approximately equal to 0.5804. So you're a little more likely to have W be greater than 2, right? And so for a sanity check, it's probably going to be the case, if all of these add up to 10, then they're probably somewhere around. Yeah, to give you an intuitive feel, each of them is going to average something like 2-ish, 2.5 to get to 10, right? Because there's no difference between them. So we should expect that it's more likely Yeah. Let me think about that. Scratch that. Yeah, so any questions on this?
I have a question about bag problems in general,
Okay,
if that's okay.
yeah, that's fine.
So there's the case. So this is a non-negative integer, and sometimes it's the case where you just want positive integers, where it's not 0, but just the positive integers. And I wasn't sure exactly how to come up with that formula.
For the positive integers.
Yes.
Yeah,
it's-
so we
I
can
don't know.
always convert.
It is in the lecture, but
Yeah,
it's explained
yes,
well.
it's explained in the lecture, but we can always convert a positive integer one to a non-negative one. So for example, if all of these were positive, then we need to we're just going to start off by assigning 1 to W, 1 to Y, 1 to X, and 1 to Z. So we would have 6 remaining things to do. Does that make sense?
So it's just like what we just did with this one, where it was
Yep.
at least 2, and
Yep.
so we subtracted it by 3.
Because we said, okay, well, it's greater than or equal to 3 in the opposite case, right?
Mhm.
So we needed to give W those 3, and then we're back to the non-negative integer case.
So since you're removing the 0, 0, 0, 0 case, you're subtracting.
Yeah, I've already assigned 3 things to W, so the rest of the bag only has 7 positions left in it.
Yeah. So in this one, if it was just, it would be W plus X plus Y plus Z equals 6.
Yes, if
And that's just because that's the number of elements. So you just subtract the total by the number of elements.
because in order for the bag to work, they have to be non-negative integers.
Yes.
Okay. We should move along. So you can come to office hours or think about it some more or ask me after. Apparently we had more space. Okay. So this one is a kind of like a checking your intuition question. Someone asked if you'll lose marks on an exam for not reducing fractions. No. I mean, don't like multiply them by 1,292 on top and bottom. Don't do that. So we have a committee of 3 people from a club with 8 sophomores and 12 juniors. E1 is the event that the committee has 1 sophomore or more, and E2 is the event that the committee has at least 1 junior. So to check your intuition, are the events E1 and E2 independent? Meaning that if I told you that E1 happened, is E2 as likely to happen had I not told you that E1 happened? So I'm asking, when you're looking for independent, you're saying probability of A given B is just equal to the probability of A, meaning you learn no information from knowing B. Yeah, I'm seeing the answer in chat. Does anyone else? I'll give you a second to think about it. Yeah, I think people think it's not independent. And so the reason why is suppose I told you that, my committee has one sophomore on it. So this is the case where this is the case where E1 happened and E1 is unknown. I can have a junior here or a junior here, or sophomores. I can have a junior here, or a junior here. So it's more likely there's going to be a junior in the case when I don't know, when nothing is known about this, than when there is something known. Does that make sense? So the fact that I know that there's a sophomore on the committee means it's less likely that there's going to be a junior on the committee, just because there's less spaces for the junior to appear. Yeah. So any questions on that while I move on? I mean, and if it's a little confusing, just think about it. And so the point of this problem is to help you build your intuition about this independence and everything. So for part B, we're asking, what's the probability of E1 given not E2? So
Isn't that just one?
yeah, it is one. I mean, it is dumb, but E2 is the event that there is a junior. Not E2 is equal to no juniors. So, so basically, if we're going to do the calculation, we're going to have the number of E1 under this condition divided by the number of samples under this condition. And that's going to be, let's see, we have 8 sophomores because we know there's no juniors. So we're choosing 3. Those are the number of ways we can choose that. And there's 8, 3, which is 1. Does that make sense to everyone, why this is 1? Okay, and C is, I mean, it's E2 given that there's no sophomores, so they're all juniors. It's 1 for the same exact reason. So that's that one.
Because all the spots are like already filled up.
Can you say that again?
Is it the possibility 1 because like all the spots have already been filled up?
It's 1 because, so we're asking, is there a, so for this one right here, E1 is saying there is a junior. E1 is the event that there's a sophomore. I've told you that there are no juniors on the committee, which means that the rest of the committee, the entire committee has to be sophomores, which means that E1 definitely happened. Does that make sense?
Yeah.
Okay, good question. Yeah. Okay, we have one more, I think. Oops. Oh, 2 more. Except we're out of time almost, so. So we have a player on a baseball team who has a 1/3 probability of getting a hit, a 1/6 probability of drawing a base on balls every time they appear at the plate. Suppose they negotiate their contract for an end of the season bonus of $1,000 for each hit and $100 for each base on balls. If they reasonably expect 600 plate appearances this year. How much do they expect their bonus to be? So we have 600 appearances, and they're all independent. So we can treat this as summing up the expectation of our new league trials. So we can just calculate what the expected value is from one appearance at the bat. So we have three things that happen. We have the probability, we have the expected value from getting a hit, the expected value from getting a base on balls, and a miss. So the probability of missing equals 1/2. So what is the expected value for a hit?
Point 3. 3. Oh.
Yeah, okay, so we have 1/3 times. So we're looking for value. So he gets $1,000 per hit. So we're expecting 1,000 over $3 for the hit case. For the base on balls, how much do we expect? I'm almost writing it. So we get
100 over 6?
Yep, 100 over 6. So that's 100 over 6. And this one, the expected value for a miss, he gets paid 0. So, 0 times anything is 0, I guess. So now we can sum these up. Miss is equal to 1,000 over 3 plus 100 over 3. 6, and that's equal to 2,100 over 6 for one appearance. Okay, so that was for one appearance. So the expected value of so we can now do hit plus base plus miss is equal to 2,100 over 6. Since each of these are independent, we can now do 600 times this expected value. And that's equal to 600 divided by 6 times 2,100. And that's equal to, so the 6's go away, 2 1s and then 4 zeros, $210,000 for an entire season. Does everyone understand how I got that answer? Yep, okay. I think we're out of time. The last problem, exercise 4, is pretty easy, so I'll just leave that. So are there any questions as
On
wrap
these
up?
discussion slides get posted up on the modules, right?
Yeah. Go look there and you can see all of our discussion scribbles. So thanks, everyone.
Is there still time to talk more about the binomial, like the non-negative thing that we were talking about? Or
Yeah, okay. So here, let me just do it down here. Right, so we have, let's say we have w plus x plus y plus z equals 10, right?
yeah,
And we say w, x, y, z are greater than or equal to 1.
yes,
So the formula only works if they're non-negative, but this is positive, right?
yeah,
So what I say is w is greater than or equal to 1. So when I'm looking at my bag, right, let's say there's, I'm literally drawing the bag.
yeah,
I'm reserving 1 for w, right? That one's reserved. I'm reserving 1 for x. I'm reserving 1 for y, and I'm reserving 1 for z. Oh, I need to stop screen share.